Get inside the shaft from this here.
Yep.
So,
oh, wow. This is amazing. It's huge, huge space carved out in the earth. People created this, and they're doing it for a project that's going to change the lives and impact millions of people. Best industry in the world. Welcome to Tokyo. This is one of the most incredible cities on Earth. The bullet train was shooting through here back when other countries were still using steam locomotives. This place was an electronics powerhouse when Steve Jobs was still working out of his garage. And it kind of knows a thing or two about building big. This place is so big, so sprawling, so huge, so well organised that it's like you're in some kind of bubble. You feel like the place is indestructible. But look a little closer and you realise there's something very different about Tokyo.
We have breaking news.
7.1 magnitude earthquake.
Wind, flood, landslide warning.
This city is constantly on the brink of disaster. Earthquakes.
Magnitude 5.7 earthquake was felt throughout Tokyo.
Volcanoes.
Mount Fuji is one of
Volcanic ash could cripple the Tokyo area.
Floods.
The disaster is far from over for
impacts
residents.
on the Tokyo area.
This is a city that really shouldn't be here, but it is because engineers have developed some of the most extensive and advanced countermeasures anywhere in the world. But it's not enough. The number of threats Tokyo faces and the damage those threats could cause is only getting worse. A quarter of Japan's population now lives in the greater Tokyo area, and the city centre accounts for more than 20% of this country's GDP. If disaster struck now, it wouldn't just be bad for Tokyo, it would have a knock-on effect for this entire country and even the world. This place, this city, really matters. But Tokyo is not exactly a city that does things by half measures. So when it came to protecting itself from annihilation, it decided to go big by building one of the biggest civic defence projects in history. I cannot describe the feeling of coming down those stairs. This is amazing. How much water are they expecting to flow through here?
This is a machine to simulate earthquake in the laboratory.
I am currently 5 stories beneath the streets of Tokyo. The goal is to achieve nothing less than total protection from everything the world can throw at it for an entire century. This is the $100 billion plan to save Tokyo. I'm so excited for this. On my way to see one of the most iconic buildings in Tokyo, the Tokyo Sky Tree. It's incredible. It was completed in 2012. The first thing you notice is it's covered in this amazing lattice structure, and that's designed to help it withstand a magnitude 7 earthquake. Now, it's only when you get up high like this that you get a sheer sense of the scale of Tokyo. It spreads out for miles in every direction. But what you also realise when you come up high is how flat the city is. You can sort of see down there through the clouds if the weather was better. This is a really big flat area. Now, because Japan is covered in mountains, cities tend to get construction on big, large, flat plains like this. But that also makes them sitting ducks for pretty much every natural disaster you can think of.
This is the Pacific Ring of Fire, a 40,000 kilometre tectonic belt.
It was this that forced Japan out of the sea in the first place, but also left it studded with volcanoes, 111 of which are still active today. And while you only need 2 plates to grind together to create some seismic activity, Japan lies across 4. Which means this one country is struck by 18% of all the world's earthquakes. And as if all that wasn't enough, thousands of kilometres of ocean to the south leaves it wide open to typhoons and tsunamis rolling in from the Pacific. Throughout its history, Tokyo has been quite literally razed to the ground numerous times. But now, with 40 million people living here, that simply can't happen again, which is why in December 2022 the city's government hatched a plan. The Tokyo Resilience Project.
Okay, now you're going to have to keep up because this is by far the biggest infrastructure project we've ever covered. Launched back in December 22, it's going to take 18 years to fully complete and cost 17 trillion yen, which is around 109 billion US dollars. This really isn't the case of a new floodgate here or a bit of earthquake proofing there. It's a meticulously planned project to protect every part of this city from disaster. There's no structure too big, no detail too small. What does that look like? Well, it means developing soft infrastructure like establishing evacuation routes and improving response times, but also building some truly epic infrastructure like tunnels. Massive tunnels!
Or widening rivers.
324 kilometres of rivers. There's so much involved because this isn't just about protecting Tokyo from one threat like a tsunami. The TRP has identified no fewer than 5 threats that could bring this city to its knees.
It might be a national symbol, but Mount Fuji also happens to be an active volcano that could blow at any moment. But even if it smothers downtown Tokyo in ash, the city is going to be cleaned up and running again in no time thanks to meticulously planned clearance routes. For those living on nearby islands, new evacuation points are being established to whisk residents away to safety on specially chartered ships.
We all remember the pandemic. Now, in a place as densely populated as Tokyo, any kind of disease outbreak is taken incredibly seriously. And one of the measures the city is now taking to try and prevent against that is the creation of more than 2 kilometres of new parks.
Extensive cycling routes are being created, as well as riverside walkways to give people an alternative to crowded public transport.
Don't you hate it when you can't get a signal? Well, now imagine that disaster's struck, the phones are down, and there's a blackout. Well, come 2040, that just won't happen here, because the city's building a new power and communications grid that's going to ensure that Tokyo never loses connectivity and never experiences a power blackout.
That means reinforcing undersea cables, building new satellite capabilities for the city, and providing cloud storage for businesses so they're always connected. And that's just scratching the surface on the measures being taken to protect the city from 3 potentially devastating threats. But all of that pales into comparison next to the last 2 mega threats facing this city. Now, before we go any further, if the scale and complexity of mammoth civil engineering projects is difficult to comprehend, then don't worry, because today's video sponsor Innate has your back. If you're working on a complex project, or planning to, you could join over 850 companies around the world which use Innate's suite of applications to keep things on track. The needs of capital construction projects change constantly, which is why Innate's modular software design means you can build up the functionality in your management system as and when you need it. Innate offers unmatched data insights, enabling you to connect workflows across all your processes, creating a single unified dashboard. That gives you the functionality you can rely on to make informed decisions and to reduce risk in your business strategy. Most of all, people trust Innate because knowledge of the construction industry runs throughout the team. Innate is built by the construction industry for the construction industry. So you can be confident you'll get the kind of informed, tailored support your project needs. To find out more about how Innate can transform your project management, click the link below.
I've come to NIED, which is Japan's National Research Institute for Environmental Hazards and Disasters. I'm here to see all kinds of fascinating experiments. But this is also the site where they have the early monitoring system for earthquakes called MOWLAS.
Set up in the aftermath of the 1995 Kobe earthquake, this is a nationwide observation network for earthquakes, tsunamis and volcanoes. Seismic activity is monitored in real time using a network of 2,000 seismometers positioned right across Japan and the surrounding ocean floor. When a disaster strikes, it's going to be detected here first.
The main control room for MOWLAS is so secret and so secure that we're not actually allowed inside it. But what you can see here on this map, this representation, is where these LED dots are, just how extensive that network of seismometers and sensors is. This is actually slightly out of date. There are now more on the land and more in the waters around Japan as well. And what stands out to you is this plain here, which I mentioned earlier, that big flat plain where Tokyo has grown up and been established. And if you look just south of Tokyo, out into the sea, you see there's a collection of islands.
Two of these islands, Izurushima and Miyake, have erupted 7 times in the last 100 years. And work's underway to establish a permanent evacuation infrastructure for when it happens again.
Volcanoes are going to be around forever. They're kind of a fact of life when living on planet Earth. And they're chaotic, they're difficult to predict. There's one other danger which is much more predictable, which has researchers very worried, because the threat of it is only getting worse.
It might not seem like it from the endless expanse of concrete, but Tokyo is a city shaped by water. It's part of the reason the capital was moved here from Kyoto. More than 100 rivers and canals flow through here, with the city dominated by the enormous spiralling moats around the Imperial Palace. But like so much else here, what actually helped this city to thrive is also its Achilles heel.
As massive amounts of rain continue to drench Tokyo, millions of people have been ordered to evacuate. At least 4 people have died and dozens more hurt.
Flooding is a critical threat to Tokyo. 124 square kilometers, a fifth of central Tokyo, lies below sea level. So the TRP is not taking any chances. Seawalls are being raised in case of a 60 centimetre sea level rise by 2100. That's more than twice as much that they've risen since 1880.
But that's not all. Tokyo faces thousands of miles of Pacific Ocean to the south, and the current from that brings a steady stream of typhoons that dumps torrential rain on the city.
Now, that's nothing new, but because of the urban heat island effect and climate change, Tokyo's climate is becoming increasingly subtropical. That means storms are getting more frequent and more severe. Over the last 40 years, the amount of heavy downfalls have almost doubled in Japan. Flooding was a daily part of life in Tokyo, and it was only getting worse. In 1992, the city's government embarked on an extraordinary project in response to this challenge. An underground system made up of 5 silos which collect floodwater from nearby rivers and channel it down a 6.5 kilometre tunnel
into this huge hall I'm currently standing in, this concrete cathedral around me. This is the Metropolitan Area Outer Underground Discharge Channel, or GCANS for short. Is a water tank. It is an enormous space, 25 metres high. It sits 50 metres beneath the city's streets, 177 metres long and 78 metres wide.
This place cost $2 billion and took 17 years to build. Now it's capable of pumping out 200 tons of water a second.
I cannot describe the feeling of coming down those stairs into this space. Huge columns, the stonework. It is a remarkable space and an astonishing feat of engineering. Now, while the scale of this place might be mind-boggling, here's the thing. The Tokyo Resilience Project is working on doubling the capacity of this system. Whoa! Look at the size of this. So I am currently 50 meters below ground inside what is a new water diversion channel. And the scale of this thing is hard to get your head around. Like, the amount of water that could flow through here is mind-blowing. This space is 12.4 meters wide. It runs for 5.4 kilometers, or at least it will do when they finish building it. And it's going to connect up to 2 other tunnels to create a network that's 13 kilometers long, the biggest of its kind anywhere in Japan.
And it takes some serious engineering to carve out a tunnel of this size. To dig this channel, engineers constructed an enormous TBM, weighing in at a massive 2,800 tons.
And this is what that tunnel boring machine looks like. This is the amazing piece of kit that has made this huge tunnel possible. So up ahead of me up here is the massive cutting head that's pushing forward through the soil, 12.5 meters wide, rotating round to dig out this huge hole. You can see here these massive segments. These are being put in to help line the tunnel wall. This amazing machine you can see just up there lifts these segments up, puts them into the newly formed tunnel to form a complete ring, and these hydraulic jacks push off that last ring to push the cutting head forwards to build the next bit of tunnel. Another ring, push forward, another ring, push forward. All that for 6 kilometers. What blows me away when you're walking down it is the scale. How much water are they expecting to flow through here?
But tunnelling through the earth isn't as easy as lifting tunnel pieces into place. To keep the earth on the other side stable, the TBM uses a water mixture known as slurry to balance the pressure of the excavated soil.
で、掘り進めた後はご覧のようにこのようにセグメントといったものをこちらのですねを掘ったトンネルにどんどん土に貼り付けていって、これを持ってトンネルの力をトンネルのですね土の圧力や水の圧力をこれで受けていくと。
So what are these 2 pipes? What do they do?
シールドマシンを掘り進める際に泥水といわれる泥水を混ぜてトンネルの先まで送り込んでます。その水圧を持ってトンネルが土の中を掘り進めることができます。また掘り進めた後には土が出ていきますので、その土をこの管を通じて地上に出していくといったその管です。
But it's not just the earth that this TBM's got to contend with. The cutter face is equipped with carbide cutter bits that are 48 times harder than a conventional TBM. That's to enable it to break through into the connecting tunnels, something that's never been attempted before.
こちらのシールドトンネルは鉄筋コンクリートの壁をシールドトンネルで世界で初めて抜いていくといった工事となります。それが非常に難しい工事の中身でした。
During a storm, this mega-tunnel is going to prevent flooding by siphoning off up to 1.4 million cubic meters of rainwater from rivers across West Tokyo. As water levels across the city subside, the water in here then gets discharged back into the rivers and flows safely out to sea. Along with GCANs, this is part of a vast network of 28 regulating reservoirs across Tokyo. 7 more facilities like that are being constructed to bring the capacity of the network up to 100 millimeters of rain an hour.
In other words, every hour, this network could pump out more rain than London gets in 2 months. And believe me, it rains in London. So why are such big tunnels like this necessary? And what would life be like in Tokyo if this wasn't here? What would happen?
こちらの施設は洪水対策の河川の施設です。こちらが東京は近年非常に雨が強くなっております。そのためこういった施設がなければこちらの流域に住んでいる皆さんの住宅、それから企業、それから東京は鉄道、地下鉄なども多いので、そういった建物が浸水してしまいます。そうしますと人の命が奪われるだけでなく、都市の機能、世界有数の都市である東京の都市の機能がストップしてしまいます。
Just before midday, on Saturday the 1st of September 1923, a magnitude 7.9 earthquake struck an area 50 kilometers southeast of Tokyo. Over 142,000 people died and nearly 2 million people were made homeless. In the fires that followed, 33,000 square meters of Tokyo were reduced to ash.
It was the single greatest natural disaster ever to hit Tokyo, and as is the way with natural disasters, there's nothing stopping something like that from happening again.
In 1995, the city of Kobe was devastated by a 6.9 magnitude earthquake.
Hundreds of thousands of residents are left searching for food, for warmth, for loved ones.
And in 2011, the Fukushima nuclear meltdown was triggered by the massive Toho earthquake and tsunami. Now, earthquakes are typically measured by the moment magnitude scale, with each level being 10 times more powerful than the previous one. Anything above level 4 poses a threat to property, while a quake above level 9 would release enough energy to power the US for over 2,000 years. Nearly 600 level 4 or higher earthquakes have already struck Japan in 2024 alone, and many are nervously predicting the big one, a once-in-a-century quake that would rival the destructive power of the Great Kanto disaster. There's nothing the authorities can do here to stop this happening, but there is a lot they can do to stop it destroying the city, and that starts with learning how to predict when a quake will strike. I've come back to NIED to see how researchers are learning to prepare Tokyo for earthquakes.
This place is amazing, this campus. It's like a Disneyland park full of amazing engineering labs. Just go into each one and see what they're doing. It's so cool. Wow, look at this. Wow. So this is the giant rock friction apparatus. It's the largest machine of its kind anywhere in the world, and I have never seen anything like it. It is huge. So what this is doing is trying to simulate earthquakes. It's trying to simulate what happens deep below the Earth's surface when an earthquake occurs. So you can see it's got these orange jacks across the top here, are pushing the top rock down onto the bottom rock with incredible force. And you can see this machine's engineered to be really strong to push those two rocks together. And then this huge orange jack on the side here creates a massive lateral force that pushes the bottom rock until it slips against the top rock, mimicking what's happening with tectonic plates deep below the Earth's surface. And what researchers and scientists here are doing is measuring data. You can see these rocks are covered in sensors. They're recording what's happening just before that slip occurs and immediately afterwards, so they can start to begin to predict when earthquakes might occur and warn people in time. So tell me about this amazing machine.
Yes, this is a machine to simulate earthquake in the laboratory. So we'd like to know what is happening during the earthquake. First of all, we'd like to understand the physics or mechanism of earthquake. And I'd like to find some hint to predict the earthquake.
The Earth's tectonic plates are constantly pushing against each other along fault lines, like the kind that Japan sits on. Occasionally, those plates slip and the energy released creates an earthquake. Now, exactly where and when that happens is what researchers are using the giant rock friction apparatus to try and find out.
I can see all these sensors on the rocks. They're collecting data about that moment.
In the similar to natural case, the fault doesn't slip at the same time. The part of the fault starts to slip somewhere and it's propagated little by little, and these sensors catch the propagation of slip.
How much do they weigh?
10 tons.
10 tons?
Yes.
And the whole machine you said to me earlier is 200 tons?
200 tons, yes, exactly.
So the data you're collecting from here will start to give you those clues and hints to look for to predict earthquakes and when they might occur. That matters because you can give people more warning that an earthquake's coming, people can get to safety in time.
I hope so, yeah.
What you're doing in this space, in this shed on campus here is really, it could change the world. It could really save a lot of people's lives.
The NIED does more than just measure what happens when an earthquake strikes. This is E-Defense in Hyogo Prefecture, about 400 kilometers from Tokyo. This is the largest earthquake simulator in the world. It shakes a massive plate on 3 axes to simulate the ground conditions when an earthquake occurs, and you can take it up to magnitude 7. It's places like this that have been essential in making Japan a global leader in earthquake engineering. But when it comes to construction, how do you build something that can withstand those enormous forces? Well, I've come to the Mori JP Tower. Completed in 2023, it's Tokyo's first ever super tall skyscraper. This place houses a mix of luxury apartments, offices and retail space. But most importantly, it kind of epitomises the extreme lengths that engineers in this city go to keep buildings standing and the people in them safe.
5 stories beneath the streets of Tokyo, directly under that super tall skyscraper that's rising above my head, you'll find this. Backup energy generators, a huge water supply fed by an underground well, extensive food supplies, batteries, an amazing series of systems that enable this building to keep running independently should the worst happen in the surrounding city. The extent of the engineering down here is incredible. Even this, a 97-ton generator, is sitting on these special springs, these special pads underneath it, that help isolate it from the rest of the structure so it would be protected from the rest of the building when it started to shake during an earthquake.
These diesel generators work alongside a massive bank of batteries in case of an emergency, so that if a disaster destroys the power grid, the tower can be completely self-sufficient. It's so safe here that the skyscraper acts as a refuge for people in the area. Inside this storeroom are enough supplies to feed 3,600 people for 3 days. These kits include everything from tinned food, bottled water, toilets, and even baby supplies. But none of this would mean anything if the building wasn't still standing in the first place. Part of this tower's earthquake defences are made up of hundreds of pistons known as oil dampers located all around the building. I caught up with Kai Toyama from the structural design team to learn more.
So this is a scaled down model of what we're seeing behind us. We're on level 33, which is here. This is level 34, and this is showing us what happens during an earthquake.
はい、これが柱コラムですけども、地震が起こると建物はこういうふうに揺れます。ここを見ていただきたいんですけども、動いているのが分かると思います。で、これがオイルの中で動いているということです。で、地震がですね終わると、これ触るとですね、ほんのり暖かくなってます。つまり地震の揺れのエネルギーが熱のエネルギーに変わって建物の揺れが収まっていくということです。
Wow. So this is another feature that helps this building resist earthquakes. What is this? How does it work?
これは粘性体制震壁と呼ばれる制震装置です。で、これの仕組みもまた模型を持ってきたので、それで説明をさせてください。 壁、この赤い壁がこの透明な壁と同じです。この赤い壁の中にはドロドロした液体が入っています。で、地震が起こると中の液体が動いているのが分かりますか？非常にネバネバした液体なので、人の力ではとても動かせません。これは地震の力でこのように動いて、先ほどと同じようにだんだん暖かくなります。
Viscous wall dampers like this. How many of them would there be in a building this big?
はい、このビルにはこのタイプのものもやっぱり300機以上あります。300 oil damper and 300 this one.
Wow, across a super tall building. Wow. What blows me away is that this is just behind a cupboard and a corridor. You wouldn't know it was there, but it's a critical feature to keep this building standing. It's amazing.
Currently, the city's evacuation centres can accommodate just over 3 million people. Now, that might seem a lot, but when you consider the size of Tokyo, in the event of a major disaster, those centres could be easily overrun. To avoid that happening, the Tokyo Resilience Project wants to eliminate the need to evacuate in the first place, just like at the Mori JP Tower. This is one of many neighbourhoods in Tokyo with fragile wooden housing which is going to be upgraded. But it doesn't stop there. Bigger apartment buildings like this are also being re-engineered so they can withstand the same level of earthquake as the Mori JP Tower. In fact, when this project is complete, 100% of Tokyo's housing is going to be able to withstand a magnitude 7 quake. In other words, if you're at home and a quake hits, you should just stay where you are. Even if an enormous earthquake strikes, the Resilience Project wants you to carry on with life as normally as possible. But it doesn't stop there. Earthquakes are devastating, and not just because of the loss of life they cause by collapsing buildings. Roads become blocked, hampering relief efforts, utilities burst, and fires spread. When the Great Kanto struck just before noon, thousands of households across the cities were preparing lunch on open stoves in timber homes. The firestorm this created helped make the event the worst disaster in Tokyo's history. Even today, the city isn't immune to these secondary effects. About 86 square kilometres of Tokyo is still densely packed with old wooden housing, which is at high risk of secondary fires. Neighbourhoods like these have been earmarked for redevelopment, which will feature new roads, tall buildings and parks to act as fire breaks.
And that's not all. Overhead wires and cables like these are prone to collapsing and starting fires. And that's why over 1,000 kilometres of roads across this city are having their overhead utilities replaced and moved underground. That's not only to prevent fires from starting, but also to improve access routes for emergency vehicles. Which brings me to the last thing I've come to see. Konnichiwa.
Konnichiwa.
So where are we now? What is this structure?
この永代橋は、関東大震災の時の復興橋梁です。1926年に施工されて、今年齢でいうと98歳です。橋の真ん中が100メートルということで、当時一番最長の橋として架けられました。現在は日本の重要文化財に指定されています。
This is one of over 400 bridges in Tokyo being retrofitted with enhanced earthquake protection. But it's also much more than that. A bridge has stood on this site for more than 300 years, with the previous version destroyed during the Great Kanto earthquake. When this structure opened after that disaster, it was a symbol of Tokyo re-emerging stronger and more resilient than ever. Its re-engineering today represents a renewal of that mission.
はい、地震が発生した時に桁がこっち方向に動こうとしますので、それを抑えるようなシステムになっています。この装置の中にはスプリングが入ってまして、スプリングでエネルギーを吸収するものになっています。こちらのものは橋のちょうど真ん中に設置してますけども、これは強軸直角方向ですね。こっち方向の大きな地震に対して
So these features we're looking at, the ones you just showed me, the ones on the side, they're counteracting the longitudinal force across the bridge, and this one's counteracting the lateral force across the bridge. They work together to protect the bridge as a whole.
はい、その通りです。地震っていうのは縦方向横方向どっち方向が来るか分かりませんけども、どの方向から来ても橋が落ちないような、そういうことで補強を行っているところです。
This project is vast, not just because of huge underground reservoirs, but also because of stuff like this. They really have thought of everything, from the biggest megastructures right down to the smallest utility cable. And that is how you protect a city the size of Tokyo from every disaster imaginable. As an engineer, how does it feel to be involved in something as huge, important and consequential as the Tokyo Resilience Project? It touches millions of people's lives. You must be very proud to be a part of it.
やはり、強靭化っていうことで、特に日本というか東京っていうのは地震が多いところです。で、そういうものに対して、都民とか市民の命とか財産を守れる仕事につけてるっていうのはやっぱり やりがいがありますし、橋梁技術というところで特化したところで仕事ができているのも誇りになってと思ってます。
There's a reason why Tokyo is at the top of so many people's lists of must-visit cities. This place is so exciting, so unique. But it's also a place of contradictions. Just when you think it's chaotic and intense, it then hits you with moments of calmness and serenity. So many people live and work here, but it's so organized, everything works so well. It's the world's biggest city, but it's put incredible attention to detail into this project to protect itself and keep its citizens safe. The Tokyo Resilience Project is like nothing I've covered before. It's so big, so vast, so ambitious, and we've barely scratched the surface of it in this video. I've been lucky enough to travel the world and see so many cities, but I've never seen any as prepared as Tokyo for natural disasters. But I guess other cities don't have to be, you know? London doesn't have to worry about earthquakes. New York doesn't have to worry about volcanoes. Tokyo's got to worry about all of that and more. Through all those disasters over the years, this city has learned. It's brought that learning from more than a century into the Tokyo Resilience Project, and it's constantly adapting and getting ready for what might come next. Because as anyone here will tell you, it's not a case of if disaster might strike, but when.
This video was sponsored by Innate. You can learn more about that at the link below. And as always guys, if you enjoyed this video and you want to get more from the definitive video channel for construction, make sure you're subscribed to the B1M.